This is the space station built by the Soviet Union more than 50 years ago. Engineers wanted to keep the station in space. He fitted the station with a rocket booster, using the force of acceleration to counteract gravity so it wouldn't be pulled back to Earth. But as the thruster was activated, the station was sent deeper into space. So engineers retrofitted the station with a small thruster from an early rocket pack. The thrusters had just enough power to push the station back into orbit. After the Soviet Union set a world record with 23 days in space, the USSR set up a laboratory in space. In order to establish a communication link between the space lab and the ground, they used radio wave equipment to transmit information. Since radio waves can only be sent in a straight line, and the space lab was traveling so fast in Earth orbit, it only had 6 minutes to communicate each time it flew over the receiver. There's no time to transmit information. For uninterrupted communication, at least 11 radio wave devices would need to be set up in different countries, and ships with receivers would have to patrol the seas. But it was hard to get other countries to agree to this idea. So engineers designed a radio receiver that could be mounted on an airplane. As the space lab passed over the plane, an operator inside the plane angled the receiver to establish a radio signal connection with the space lab, until it was out of range of the airplane. Another plane would take over the communications. In this way, only 8 airplanes were needed to circle the globe and maintain uninterrupted contact between the space lab and the ground. However, this method was soon eliminated because airplane pilots had to be highly skilled to keep track of the space lab. Now, engineers have launched 9 satellites above the space station, thousands of kilometers from Earth's orbit. Every time the station sends out a signal, the closest satellite picks it up and transmits it to the ground control center. That solved the problem of communicating between the station and the ground. At that time, the United States wanted to build a bigger space station, so they had to work with other countries. So docking between space stations became the next challenge. The air pressure inside the Russian capsule is exactly the same as on Earth. Inside the American capsule, it's pure oxygen at a much lower pressure. If the docking is successful, it will cause damage to the high pressure inside the capsule. So the engineers added a depressurized chamber in front of the docking capsule. The astronauts just have to wait inside, when the pressure inside is the same to complete the docking. To make the space station bigger, every astronaut had to work outside the capsule. Early spacesuits were filled with thermostats. Oxygen and electricity are transported inside the suit through a long tube. This umbilical cord-like tube not only limited the astronaut's range of motion, but it could also get tangled and cause oxygen deprivation. So engineers removed the tube and replaced it with a removable backpack. It contains enough oxygen and batteries, as well as coolant and heating fluid to keep the astronauts warm. Meanwhile, there's a control panel on the chest of the suit. The astronauts can see the data and operate it by simply looking through a mirror on their arm. Although the suits are more flexible, the astronauts still can't assemble the space station smoothly, because it's hard to put together a capsule that's dozens of tons. They had to be moved with the help of a robotic arm. So engineers designed a unique robotic arm. It simply attaches to the space station's interface to help astronauts build it. Once the station was roughly assembled, the power supply was the next problem. It's not easy to fine-tune the orientation of such a large building so that the solar panels are constantly facing the sun. So engineers fitted the station with a special kind of gyroscope. It works like this wheel. When it turns, it moves in one direction. And when you stand on this wheel with it, you're driven. If you want to change the direction, you just reverse the wheel. The gyroscopes on the space station use this principle to fine-tune the orientation, to keep the solar panels facing the sun for power. Although the station has an endless supply of electricity, but the internal oxygen supply was the next problem. So engineers installed a life support system in the station. It uses electricity to break down water into oxygen and hydrogen. and then it's piped inside the station. The system also electrolyzes fresh oxygen from sweat and urine. The current space station is so big, it's easy to get hit by space junk. Larger pieces of junk are tracked by radar and guided out of the way. But junk that's barely visible to the naked eye is harder to spot. It's fast enough to penetrate the station's shell, so engineers have wrapped the station in layers of the same material used to make bulletproof undershirts, so that even if small particles of junk penetrate the outer layers, they won't damage the inner layers. And that's how they built the perfect space station.